We're going to be talking about parts of an atom today. Really important foundational stuff for chemistry. You got to know this stuff. We'll use it the rest of the year. You had this in middle school at some time. Some of this should be a review, but make sure you get this. Parts of an atom. Very important. So let's start out with a picture, right? We know these pictures, these models are not drawn to scale, right? We watched that video the other day that talks about the electron levels, right? There's no way they're this close to the nucleus. The atom's mostly empty space. We talked about the size of the electrons, right? They are way smaller, way smaller than that. So these aren't drawn to scale, but they are very helpful to just know and know kind of what's going on with the atom. So let's start with what we have in the middle, our good old protons, right? So these are the guys with the positive charge. They're found in the nucleus. This was Rutherford's experiment that figured this out. And he found that protons were positive and that they have a mass of 1 AMU. What is an AMU? An AMU stands for an atomic mass unit. And you may ask, what is an atomic mass unit? Well, it's our unit for measuring atoms. So I'll just say that for now. We'll talk more about that as time goes along, but that's protons. What else is in the nucleus? Well, you see it. There are these green guys right here. That is a neutron, right? They are also in the nucleus. They also have a mass of 1 AMU, so they're about the same size as a proton, but don't get this confused, they have a neutral charge, which means a charge of 0. They don't have a charge. So students often get neutrons and electrons confused. Make sure you don't. And then finally, our electrons, right? These guys revolve around the nucleus in orbitals. And their charge is negative. And notice their mass, because they are so small, we really just say they're almost 0. They're approximately 0. So that's important. They don't take up any of the mass of the atom. So where is the mass of the atom? Right there in the nucleus. Protons and neutrons make up the mass of the atom. Really important. Okay, moving on. Let's talk about how this looks on the periodic table. We have 2 numbers on the periodic table, and both of them are really important. Our first number is called the atomic number. And what does this number tell you? It tells you the number of protons. So helium, the atom helium, as we see right here, has 2 protons. It also tells you that it has 2 electrons. Now, little asterisk right there, it says in a neutral atom. And we'll talk more about this as time goes along, but the atom has to have a 0 charge because there's an equal number of protons and electrons. That would give us a neutral atom. So atomic number tells us both of those things. Okay. The other number is atomic mass. Atomic mass, you see, is in AMUs, right? Because we measure atoms in AMUs, and notice it has some decimal places here. So atomic mass tells us the number of protons plus neutrons. Because remember, we talked about this. I'll draw it again. What is in the middle of the atom? Well, for this one, for helium, it's going to be 2 protons, and we're going to see that it's 2 neutrons. What is the mass of the atom? It's going to be approximately 4 in this helium atom. So the only thing we need to know now is how do we find the number of neutrons? And I put the formula for you down there. It's simple. We take the atomic mass, right? This is always going to be the larger number, and we subtract the atomic number from it. So what we like to do, because we can't have 1/10 of a proton or 1/10 of a neutron, is we simply take 4 minus 2. We round that 4 to the nearest whole number, and we get 2 neutrons, which, as we see right there, are the 2 neutrons in the nucleus. So atomic number, atomic mass, really important to know how to distinguish those and how to find the number of neutrons. Okay, a few different ways of writing this. It can be a little confusing, but let's iron this out. We call this, first one, we call this shorthand notation. And You may be saying, Mr. Jones, you just showed me on the periodic table, you showed me that the atomic number was above and the atomic mass was below. Why is it switched now? I don't know, to be honest, but here's a good way of always knowing. Number one, the atomic number is always the smaller number, and the atomic mass is always the larger number. And there's even a better way, I would say. Get out your periodic table. You can use this all the time. You should use it all the time. All I have to do is go find carbon. Notice it is atomic number 6, and that tells me, hey, the atomic number is 6. This has to be the atomic mass, right? Okay, there's one other way you see this written. Sodium 23. Well, the first question is, what is that 23? Is that atomic number or is it atomic mass? Again, I would say go to your periodic table. Find sodium. I see that sodium is the atomic number of 11, and I see the atomic mass is 22.99 or 23, right? So this is the atomic mass. And there's a few other examples of this. Carbon 12. If I'm not sure again what that 12 is, I just go to my periodic table. I see that carbon has an atomic number of 6 and an atomic mass of 12. So we also call this shorthand notation. It's just a different kind, and this is the element along with the atomic mass. So don't be fooled by that number. That is the mass, not the atomic number. Okay. And lastly, let's practice a little bit. You're going to be seeing this a lot in this unit. You're going to be seeing this really through the rest of the year. You're going to have to know how to find the atomic number, the atomic mass, and what that corresponds to protons, neutrons, and electrons. So let's start with boron. This tells us our element. It's boron. So I find it on the periodic table, and it looks like the atomic number is 5. Well, that information tells me atomic number is equal to number of protons and number of electrons in a neutral atom. So what do I have left? Number of neutrons. And what do? I take the atomic mass, I subtract the atomic number. 11 minus 5 is 6. All right, the second one, we don't know the element, but we know the number of protons. So if it's 9 protons, the atomic number has to be 9, which is fluorine. If the number of protons is 9, then the number of electrons is also 9. And, oh, I switched this up. I'm sorry. This is fluorine, which would mean the atomic number is 9. I got a little excited there. Okay, and the mass number, or the atomic mass, would be number of protons plus neutrons would be 19. Great. Moving on. Bromine. So I look down on the periodic table, find the atomic number is 35, which means I have 35 protons and 35 electrons. What am I missing? I'm missing the mass. So what is the mass? It's the number of protons and neutrons in the nucleus. So we're going to have a bigger number here. 35 plus 45 is going to give me a number of 80. And the last one, what do we have? We don't know what the element is. We do know the number of protons, which tells me the atomic number is 25. And what is 25? It is the metal manganese. Manganese. What do I have left? Number of electrons would also be 25. And number of neutrons, what do? I do mass number, or atomic mass, minus atomic number. 55 minus 25 is going to be a big 30, right? All right, so we'll be doing that practice all the time. Hope that helped.